In this video, I run through everything you need to know about direct and inverse proportion for the higher level at GCSE. So let's start with direct proportion. Well, in the foundation video, if you've watched that, if you haven't watched that, maybe you want to go back and have a look at that if you're new to proportion, if you don't understand it. But basically what we did is we drew out a t-table and we used that to solve, or we might get told that when x equals 4, y equals 8, and we use that to solve for y when x equals 12. We do the same thing to both sides, and that's quite easy. All it is, times both sides by 3, for example, and you get your value of y. I also showed you that we can have equations for proportionality, for direct proportion. For example, y equals 3x. You shove, I don't know, you shove 12 in as x and you find out what y is in that relationship of proportionality. But in higher, the step up to higher, you have to be able to create those, and you're going to be asked to create those, and you're going to be given questions that are more complicated than this, that basically are just easier to solve with the equations. So I'll show you how to do this. You may remember that I showed you that when two variables are directly proportional, whatever they are, to get from one to the other, you're always doing the same thing. So from 4 to 8, timesing by 2, from 12 to 24, we're timesing by 2. And what this means is that when x and y are directly proportional, to get from x to y, you're always timesing by the same thing. And we're going to call this k. K is the number that you multiply to get from x to y. And k is the constant of proportionality. It's a constant because for this proportional relationship, it's always going to be 2. Okay, for a different relationship, it might be 3, for example, as you can see by this equation. So basically, what you can see here is that, well, let's write it out. X times k equals y. Tidy things up a bit using our algebra knowledge. This is how you would write it. Y equals kx, y equals k times x. See a relationship? So in this equation of proportionality, k equals 3. So to get from x to y, always multiplying by 3. So this isn't this one, because in this one you can see k is 2. So we would simply write this out as y equals 2x. And there we have an equation to represent our relationship of proportionality. And that's what we're doing, essentially. That's all we're doing. What about inverse proportion? Because inverse proportion, as we know, it's not direct proportion. We're not going to be seeing this exactly. Y is directly proportional to 1 over x. Y is inversely proportional to x. Sorry. X and y, as I showed you on our t-table, maybe we have 4 and 6. When we do something to one side, we're doing the opposite thing to the other side. Let's try here, because we're going from x to the y in direct proportion. We're getting the same thing. What happens if we do this for inverse proportion? Well, to get from 4 to 6, we're multiplying by 1.5. To get from 8 to 3, we're multiplying by 3/8. You can see that's different, can't you? Because we're not going from x to y and it's the same thing every time, because that would be direct proportion. This is inverse proportion. But this reads y is directly proportional to 1 over x. So what if we do a t-table 1 over x and y? Well, the inverse of 4 is 1 over 4, and 1 over 8, and then 6 and 3. To get from 1/4 to 6, we're timesing by 24. To get from 1/8 to 3, we're also timesing by 24. So for inverse proportion, and this is illustrating why it works, basically, because by the end of this video, you should be just doing this automatically. To get from 1 over x to y, we're multiplying by a constant, our constant of proportionality, k. And in this case, it's 24. So we would write this as 1 over x times 24. Well, let's write it as times k equals y. And to tidy this up, y equals k over x, because we're multiplying k by 1 over x, and that's how we simplify it using fractions. And in this case, k is 24, so you'd write y equals 24 over x. Sometimes you might see a question that says y is directly proportional to the cube of x, or the square of x. That means y is directly proportional to the cube of x, x cubed. That's just a little wording trick. So you would write y equals k x cubed, solve from there. Because basically, the step up from foundation to higher is going from our relationship of proportionality here to our equation that represents the relationship here, and you use this equation in the problems that they give you. I'm going to show you two problems here, but before I do so, if you want to get more comfortable doing this and tackling questions like this, head over to websites like Corbett Maths, Maths Genie. You can find lists of questions online where you can basically just practice here, practice doing this stuff. The answers are included. Obviously, the exam questions are going to be slightly trickier, so we're going to have a look at them. Here is one, question 16 from a real GCSE Maths exam paper. Pause and have a go. Well, here's the solution. Well, y is inversely proportional to the square of x. So what you do for proportionality exam questions in higher is you begin by writing out your relationship. Y is directly inversely proportional, so we know it's going to be 1 over x, and we're told it's the square of x, so it's 1 over x squared. Y is directly proportional to 1 over x squared. Then we turn it into an equation, as I showed you how to on the previous slide. It's going to be y equals k over x squared, because that's where we put the k for inverse proportion, because we're timesing by k. It then goes on the top. So now we need to solve k, and because in questions like this, we want to find out what k is without using our t-table. We can do it without using the t-table, just by using our values here. We're told that when y equals 8, when x equals 2.5. Well, we can substitute those values in, can't we? 8 equals k over 2.5 squared. And if we simplify that, that's 6.25. 6.25 times 8 is 50, equals k. And there we go. We have our value of k. So I like to go to a new column, but you can do what you like. They're your workings as long as they're clear. Y equals 50 over x squared. And we found our equation that represents this particular relationship, y equals 50 over x squared. And let's get to what that question's actually asking us to do. Probably should have read this at the start. You do read it at the start. Don't just rush in like me. But you'll see that we want to do this anyway. We want to find the negative value of x when y equals 8/9. Negative value, that might seem scary. That might put students off, but don't worry about it. Just do what you've been taught. Do what you've practiced over and over again in your revision, and you won't go wrong. So to solve for x, we want to substitute in y. So 8/9 equals 50 over x squared. Now, to someone that doesn't know algebra, someone that struggles with algebra, this might look very nasty to solve. I get that. So, but basically, when you've got fractions, you generally want to get rid of the fractions to solve them. Let's start by timesing both sides by 9. That gives you 8 equals 450. 50 times 9 over x squared. Let's times by x squared, get rid of the second fraction. 8x squared equals 450. Let's divide by 8 from both sides on your calculator, because it's not very fun to do with your head, although you could use the bus stop method, understandably. That's going to give you that. And then we're going to square root both sides. And remember, when you square root, you're going to get two answers. You're going to get a positive answer and a negative answer, and that is particularly important for this question, the negative value of x. And this is where some students might get a bit confused. They might say, well, x equals 7.5. How can this be? And they'll only get 2 out of 3 marks. So your negative value of x is going to be negative 7.5. And that's your answer. That's 3 marks. That's simple. You know, you can do that. You can practice that loads of times. Again, websites like Corbett Maths, really good for this kind of thing. Let's go and look at a grade 8 or a grade 9 question that might come up near the back of your exam paper. So first things first, let's look at it. You've got 3 variables now. Straight off the bat, this might make students skip the question because it looks scary. But when, you know, the hardest questions at higher, you're not going to look at the question and be able to see how you're going to get your answer really quickly. It's not going to be something that you've practiced. It's going to be something new that you're going to have to apply your knowledge of the topic to a new question. And this is exactly it. So all we have to do is we have to do exactly what we've practiced and then you get the answer. It's honestly that simple. So let's start with the first sentence and do what we've been taught to do. X is directly proportional to y. Don't be put off by the fact that the variables are the other way around. We can simply write it out. X is directly proportional to y. And then do what we've been taught. Turn it into an equation, because that's really important at higher. X equals ky. And then we're told y varies inversely with the square root of x. Varies inversely means inversely proportional to. It's just like a wording trick that examiners like to use. They like to try and trick people. So y is directly proportional to 1 over the square root of z. And let's turn it into an equation. And so you put the k at the top because you're multiplying by something to get from z to y, aren't we? Because it's direct. Yeah, we know how to do that. Now, quick thing here, these are two different proportional relationships. So k here is not going to be the same as k here, and that's quite important to understand for the question. That's a bit of higher level knowledge there. So we're told, and this appears in all the questions that you've practiced, when x equals 6, y equals 2. It's just scary because then you have and z equals 81. There's nothing to fret. Just substitute in what we know. 6 equals k times 2. We don't have to have an equation with all three in them. We can just use two of them. 2 equals k over root 81. And then we can solve both of them. 3 equals k and 18 equals k. And then we can write out our two equations just like we've practiced over and over and over. And we get y equals 18 over root z. And then we get on to the actual bit that it's asking us to do. Find the value of z when x equals 2. Can we put x into an equation to get z? No. Can we get y and then use our value of y to get z? Yes, we can. So that's exactly what we're going to do. We're going to try that. Because if it's something you've been taught, if it's something that you can do in maths, then nothing's stopping you from going ahead and trying it, even if it's wrong. So we find out that y equals 2 over 3 when x equals 2. So we can then substitute that in over here. 2 over 3 equals 18 over root z. And now we can simplify that. 2 equals 54 over root z, multiplying both sides by 3, and now multiplying both sides by the root z to get that, and then divide both sides by 2. Just solving algebraic equations. Root z equals 27. How do we get z on its own? Well, we've got to square both sides to get z equals 729. And suddenly we've got our answer. That'd be 5 marks in an exam, and you've just smashed it with the knowledge that you have. So that's a really key point to take away when doing harder questions. Either you won't know how to get to the answer, just use what you've learned, have a go. Even if you don't get the final answer, you're going to pick up 2 or 3 working marks, and that's the difference between grade 6, 7, 8, and 9. It's the amount of working marks you get for those higher questions. Just set it out in a clearish way, and you'll be fine. So this is everything you need to know essentially about direct and inverse proportion. Hope this was helpful.